Go. Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Manager for Dataversity. We'd like to thank you for joining today's Dataversity webinar, Data Architecture Strategy, sponsored today by Clover ETL. It is the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. If you'd like to chat with us or with each other, we certainly encourage you to do so. Just click the chat icon in the upper right-hand corner for that feature. For questions, we'll be collecting them via the Q&A in the bottom right-hand corner of your screen, or if you'd like to tweet, we encourage you to share highlights or questions via Twitter using hashtag DataEd. To answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days containing links to the slides. And yes, we are recording, and we'll likewise send a link of the recording to this session as well as any additional information requested throughout the webinar. Now let me turn it over to Pavel from Clover ETL for a word from our sponsor. Pavel, hello and welcome.
Hello, Shannon, and thank you for the warm welcome. So, good morning or afternoon, everyone. I'd like to spend a few minutes on this webinar to talk about the synergy between data architectures and data integration. I'm from Clover ETL, a data integration platform built by IT professionals for a data-intensive challenge or data-intensive challenges. And I'm joining Peter here today because I think there's a lot where data integration can support data architectures, and all the interesting things that Peter will be talking about today and aspects of data architectures and how data architectures can benefit the business are actually supported by data integration. They can be supported by other means as well, but data integration typically is an integral part of that. So in a way, it's one of the thickest pillars on which data architectures are built on. To ease us into the webinar, I have a rather funny analogy. If we look at data as a carrier of information, then a data architecture would be the organization of these individual pieces. It's the governing regulations, it's the relationships, it's everything that sort of puts it into some form and some order. Then data integration is the sort of communications and transport layer that enables to fulfill these relationships, enables to those exchanges and data paths. So what can data integration do? And I've chosen 2 recent examples that we did for clients, which I find interesting and sort of reaching beyond the typical scope of what data integration, or let's say ETL in the past, is known for, which would be like operating some data architecture, right? You use data integration to connect to data sources, typically different kinds of data sources, so that might be a challenge on its own. Then you need to transform and join the data in some way so that it's usable in some target or published, let's say, as a data as a service. But what I want to be talking about is other uses of data integration platforms. And we have a client who uses data integration to not only operate a data architecture, but also to develop it, to characterize the data they have, to help modeling with a modeling tool and a data integration tool, and then run tests before they put it into production. So I have a very simple chart here. This is, by the way, quite a large bank, and they have a group dedicated for trade risk assessment, and they operate an architecture where they pull data from trading systems and some other systems, and they put it into one central repository. What's interesting is they use IDA to do all their data modeling. They have an offshore team that produces data models, but they have a gap. Like, how do they turn these data models into production somehow quickly? And that's where they start using Clover not only to run the architecture, but also to transfer the models into executable and testable, what I call jobs, something that can run and can be used immediately. That has a significant impact on how they run their business. This rapid, automated, and inexpensive iteration of model to production makes them shorten the time it took originally, which was 9 to 12 months, to implement changes in the models to production. Now they can do it in 3 or 4 weeks. So significant changes to how the business can react to new requirements and needs. What else can data integration do? Well, I have another example. If you have a large organization, you typically see they build like siloed data architectures. You have a department that builds something for themselves, then you have marketing that builds their own reporting database or whatever. And what data integration can do is it can help you glue these silos together without having to redesign everything from scratch, waste that investment into the individual architectures, but you can keep them, but you can make them work together and not get isolated. So these are two interesting examples of using data integration in ways that are not like typical ETL. So thank you for your attention, and I'll be listening to Peter now with you because I know it's going to be interesting. So thank you, and over to you, Shannon.
Well, thank you so much, and thanks again to Clover for sponsoring and helping us to make all of this happen. And just to give you an introduction now to our speaker for the day, Peter Aiken. Peter is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years experience and has received many awards for his outstanding contributions to the profession. Peter also is the founding director of Data Blueprint. He has written dozens of articles and 11 books, and the most recent is Your Data Strategy. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise, and Peter spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. And I see Peter's slides are up there. There we go. It's looking awesome. And with that, let me turn everything over to Peter to get today's webinar started, or I should say continue today's webinar. Hello and welcome.
Hi, Shannon, and thanks for muting me earlier when I was making too much noise on my keyboard. I apologize, Pavel. I was in a side discussion with somebody. But Pavel, yes, the real key to this is that data architecture is not really well understood, and that's our goal collectively here today, to walk you guys through some of the important aspects of what data architecture is, but that it has uses very much beyond what most people in the profession actually think it is too. And so I really appreciate Pavel's ability to connect the data architecture to business outcomes in there. So where I like to start on these things is to say that data assets are really unique as far as organizational assets. In fact, I'll go as far as say it's the most powerful, underutilized, and poorly managed organizational asset that we have. In fact, it's the only asset that we have that doesn't deplete over time. It will be available for subsequent use. It doesn't degrade over time. It cannot be used up. And it is durable in nature, which is a physical term. By that I mean a financial term. Durable assets are ones that you invest in more that you hope will return even greater returns to the organization overall. And at the strategic level, it's the only one at the strategic level that lists those characteristics, meaning that data assets really do win when you look at what's going on out there. I was over in the Middle East earlier this year, and they love the phrase data is the new oil, but I tell you, even though when you Google this phrase you will see 5 million hits, it is the wrong way to think about data. Because if you think of data as oil, my first question is, do you ever think about what happens to the oil when you're done with it, when it's turned into carbon and everything else that goes on? Data and oil don't work very well. Oil is a production and delivery type of process. Data has those aspects, but you're missing an important aspect of it as well. So when I see people with this written around or getting excited about the phrase data is the new oil, I say let's put one letter in front of it. Now, if there's any gardeners on the call, you guys will be able to empathize with me. First of all, when you are planting things in your garden, you do not just randomly walk around your yard and drop seeds on everything. It doesn't work that way. You need to prepare the soil. Of course, architecture is fundamental to that aspect of it. The other part of it is that you do not plant tomatoes on Tuesday and expect to eat them on Thursday. It just doesn't work. It requires some time to grow and nurture. So gardening is a much better metaphor for this. But if you want to call it bacon, if that's what works for your organization, that is just terrific. As such, however, data deserves its own strategy. It deserves attention on par with similar organizational assets. Typically what we have is an HR manager, a physical manager sitting around the table, and the data manager is buried somewhere in IT, and that doesn't give it the ability to be used as the leverageable asset that we'd like to have it. And most importantly, it doesn't recognize that we do need some professional administration to make up for the past neglect that we have not given data up to this point. So what we're going to talk about today is look a little bit at data management, just very, very briefly. I'd like to give it a context and then talk specifically about what is data or information architecture, why is it important, and what do we mean when we try to use it in an engineering sense? And the answer to that, of course, is leverage. Then we'll look at a specific case study around that and get to some takeaways, references, and of course some Q&A. And Pavel, we are looking forward to your participation in that as well. So let's get started. First of all, when we look at what's happening out there overall, I like to start out the architecture one with a Dilbert. The PHB says, Alice, we have a new corporate policy, and I quote, initiate the description of the criteria for requirements by developing a framework for the application architecture that is consistent with the planning corridor specified in our strategic initiatives. I'm willing to bet that most of you have a memo somewhere in your organization that says something like that. You'll remember Alice is the smart engineer. She says, oh my gosh, I'm so tired. Wham, her head hits the keyboard. The PHB, pointy-haired boss, says, did you get all that? And he goes and grabs Wally out from the hall and says, read this and tell me if she's doing any of it right now. They don't know. What everybody does remember, though, is Maslow's hierarchy of needs from back in high school. For some reason, everywhere I go around the world, everybody remembers their lessons in Maslow. If you don't remember the specifics, what it says is that if you are missing food, clothing, and shelter, your physiological needs are unmet. You cannot be safe. If you are not safe, you can never belong to a larger group. If you're not part of a larger group, you do not have your own self-esteem. And finally, what we'd like to get to, of course, in the long run is self-actualization. This is now called flow and all sorts of other things, but it's the same thing. It's the ability to go in and work at your highest potential. And data management, we talk about a parallel structure in the sense that most of the fun things that people are looking at, the shiny objects, that people think that if I just buy a particular software package or something like that, that will help to solve the problem. And yes, we do need tools, but we also have to recognize that everything we're talking about there is just the tip of the data iceberg that we're all facing on this. And that when we look at the rest of the iceberg down there, there are some fundamental practices that we need to put in place: governance, quality, strategy, architecture, and operations. If we don't have them correct, then everything we're trying to do at that self-actualization advanced data practices level is simply going to be more difficult. Now, the things on the top are technology focused, and the things at the bottom are capability focused. And that's really a lesson I would love everybody to take away. Being good with data architecture is one of the foundational data management practices that your organization must have the capability to understand, not just to do the modeling, but to actually figure out how the modeling will help the organization in the long run. Now, we're always asked, Peter, I know you can do this stuff and I know you'd like to do it, but you know, my boss wants it by Friday. And so, yeah, if you want us to do this faster, then it's going to take longer, it's going to cost more, it's going to deliver less, and it's going to present greater risk to the organization than if instead you learn to crawl, walk, and run your way up the top of that pyramid. Now notice I've taken those 5 foundational practices and moved into another component of this, which is something that our colleagues at the CMMI Institute do. We usually do a webinar with them once a year as well, but the DMM is CMM for data. And what this means is that we're looking at strategy being the ability to coherently manage our data. Right now in most organizations, data is managed very well at the workgroup level and rather poorly at the organizational level. We now have a class of managers that know how to do this as a profession, which we didn't have 20 years ago. We can take and very quickly evaluate whether data is fit for specific purpose using the right architecture and using the right processes around that. We need some supporting processes in order to make it all work, and there is now our 5-point scale from the CMMI Institute. I'm going to give you a very quick example of architecturally how this is important. You get 1 point just for showing up. You get 2 points if you are repeatable, 3 points if you're documented, 4 points if you're measured, and 5 points if you actually try to improve the overall process. Again, we'll do a whole hour on this later in the year in order to do this, but I'm going to, just for the purpose of illustration here, say that this hypothetical organization that I'm talking about has gotten to the point of documenting their data governance, their data quality, their platform, their architecture. There are 3 in those areas, but for some reason this organization does not have a plan. And because it doesn't have a plan, it only gets 1 point, which means the strength of this entire data management architecture here can only be as strong as the weakest link. It doesn't matter how much more money you put into data quality. If you don't make that one a 3, you'll never make any of the 3s into a 4. This is, of course, completely consistent with our data management body of knowledge. We now have the version 2 that's out there, and again, we've talked about maybe doing a piece on that as well, but you can see that architecture is a very important piece. So let's talk about what is architecture. Not data architecture, but architecture. And architecture is about things. It's about what those things do and how those things interact. I won't play all the video on that, but those little characters will come back and dance quite a bit on this. So data architecture management is then defining the needs of the data needs of the enterprise and designing the master blueprints to make those needs a reality on this. And in the DIMBOK version 1, we had this one slide that took care of the overall description. This is an input-output process slide. If you take nothing else away from this webinar, this is a slide that will help you quite a bit, and we've seen this up around the world on cubicle walls. So the inputs are the business goals, the architecture, the strategy, and the activities are understand the information needs. Again, I'm not going to read these all for you, and the deliverables are the things that come out on the other end of this. We will refer back to this slide a lot. It's just sort of a one-slide description of what goes on there. So let's dive a little further now. Architecture, as usual in English, we're not very good with labeling things, so architecture is both the process and the product of planning, designing, and constructing space in this case. So it allows us to go in and encompass everything from urban systems design to the construction of a chair in a specific room. All of these things are incredibly useful. What's really interesting, though, is that most people don't understand that architecture is always with us in every form. So we get a lot of calls at Data Blueprint here to say, hey, will you come and create a data architecture for us? It's like, we could do that, but you know what? Your organization already has one. And that architecture then becomes a question of, do you understand it? Because if that architecture is not documented or it only exists in one person's concept in here, it cannot be useful to the organization. And therefore, you cannot actually hope to make any improvements around it. So architectures are the symbolic representation of the structure, the use, and reuse of resources. Common components are represented using some form of standard notation, and architectures are sufficiently detailed to permit both business and technical personnel to read the same model and come away with the same common understanding. Because if we don't understand the architecture, we have no ability to be able to utilize it in larger contexts. So I'm going to give you a couple of examples. These are kind of tongue-in-cheek, but kind of not. So this is a little joke we got off the internet a while back. It says, Amazon, hey, it's got a fairly traditional structure with lots of businesses, but Google revolves around 3 people up there at the top back when they were a team of 3, right? Facebook, of course, is network structure. Do you really have a structure? Microsoft's kind of infighting, a little joke there on it. Apple, Everything is centric around one particular individual. Again, you can tell these are kind of old. And Oracle has some engineering skills, but also some really strong legal skills to it, too. Now, you can see these are not necessarily correct, but you get an idea that the architecture follows the function of the organization, and should. Organizations will typically manage a number of different types of architectures, or try to manage these types of architectures. Process, systems, business, security, technical, data are just some of the many things. Our experience is that about 1 in 10 organizations actually do this well. That's a little problem, because if management perceives that all you're doing is having committee meetings and you're not actually producing any value, you've got to be able to go back and deliver something to them. Now, I'm very frustrated with our colleagues in the field here, because there are a lot of definitions of information architecture. So we're moving from architecture to information architecture specifically. And again, very good friend of mine, Jim, put this one up. Underlying information design principles among which construction is based. Yes, absolutely correct, but I don't like the definition. There are plans guiding the transformation of strategic information needs. No, I don't like that either. A framework for providing structured description of an enterprise's information assets. No. By the way, this is a terrific book, Information First by Roger and Elaine Evenden. Very good information architecture book, but their definition is problem. Can you imagine getting in an elevator with a executive and they say, so you're our new information architect, what do you do? And you say, well, I provide foundational discipline describing theories, principles, guidelines, standards, conventions, factors for managing information as a resource, producing drawings, charts, plans, documents, designs, blueprints, and templates, helping make everybody efficient, effective, productive, and innovative in all types of information. No, again, I do not like it. Even our Dimbach definition, defining the data needs of the enterprise and designing those master blueprints, I consider that to be inadequate. So let's move a little further. Why is it important? Well, it really goes back to our definition. Information architecture is a common vocabulary. If you tell an executive you're making all of their systems and people speak the same language, they will know absolutely what it is that you do and the value that you bring to your organization. So again, a structure of data-based information assets, now not database, data-based information assets, supporting the implementation of strategies. Most organizations have strategies that are not very helpful to that, and consequently, they aren't able to leverage that particular strategy. We're going to come back to this in just a little bit, but the diagram on the right here for this chart is actually from a web architecture. So if you have trouble finding people in your organizations who understand information architecture, go to your web people, because they are concerned with making the connections between people visiting your website and getting the information that they need to have. So they understand very, very well the purpose of an information architecture. Probably not as broadly as the majority of you all do, but nevertheless, it'll be a starting place for everybody. In fact, if we look a little bit more, just to give us some context here, a software engineering architecture may span a program or a set of programs. A database architecture may do the Brown database there, that is keeping track of programs A, B, and C, providing information integration across them. But the real question is, who's looking at what's going on over with the green database or the orange database? So information architecture has a focus on a much broader business perspective than either software or database architecture. The analysis scope is on system-wide use of the data and the problems caused by data exchange or lack thereof it. So the goals are much more strategic rather than operational. Data architecture is poorly understood because we do a terrible job in most college and university curriculum of even introducing the concept. It's inarticulately explained, it's indirectly experienced in the sense that people say, well, the system doesn't work. Yes, that's true, but I'll give you an example in just a minute here of a poorly thought out software purchase that can be obviated by the process of understanding the information architecture better. Now, this is an old example. This actually comes from a 90s system that I worked on when I was with the United States Department of Defense. You can see here it's got some things. We're talking about a person and an employee and a position and a job class. And if I look at the business rule that links the person entity to the employee entity, now those of you that aren't real familiar with data modeling, when I talk about an entity, it's a class of business things about which we create, read, or update information. And I give this example here. This is a correct interpretation. A person can be related to 0, 1, or many employees. Well, again, that's geek speak. And if we speak only geek, particularly to our colleagues in IT as well as in the business, we will have a big problem, because what these folks understand this concept is as moonlighting. I want to be able to show that an employee can be working for our system here, and our system, they can be an employee for one part of the organization, but they can also be an employee for another part of the organization. You might ask the question, under what circumstances does a person have multiple roles as an employee? And the answer, in this case, I mentioned it was the early 90s, about 30% of the DoD workforce actually had a second job within DoD. So we had the choice of either processing the payroll manually for 30% of the folks, or making sure that we had a system that actually supported this. This little small architectural component guided the selection of the final DoD pay and personnel system that we put in place many, many years ago. Another example on the same screen here, the other business rule that we have is that we have 0, 1, or more employees can be associated with a position. Well, that doesn't mean anything to anybody, but if we talk about it as job sharing, somebody may want to have the job on Monday, Wednesday, and Friday, and somebody else have it on Tuesday and Thursday. If your system doesn't provide that type of information, then it'll be very hard to understand what software is going to complement your existing practices instead of inhibit those specific practices. It is so bad, in fact, that we've seen queries out there where we see people who look at something like this. Now, this is not an information architecture, but it's certainly a query that is going in, and these folks didn't understand the process of optimizing the query, which gives us better results. Never going to promise easy, but lack of this understanding happens to organizations hundreds, thousands, and millions of times daily, which means that organizations are suffering death by 1,000 cuts because they do not understand the value that information architecture can bring to their organization. When we look at the question, how does a poor data architecture cost money, consider the opposite question. Were all of your systems explicitly designed to be integrated or work well together? The answer to that may be yes or no, but if not, what's the likelihood that they just will happen to work together? Data is the most granular concept that we have in systems, and if we don't design the systems to explicitly accept the granularity of the data that we have and the types of data that we have, they cannot be useful. Organizations spend between 20 and 40% of their IT budgets evolving their data, migrating it, converting it, improving it. And all of these things allow us to get to business value once we understand how it is used. So the goal is shared business understanding. If we have no disagreements, there's probably insufficient communication. The data sharing is largely automated, thus dependent on successful engineering. Again, we can't have people doing this by hand in most cases. The modeling characteristics change course over the type of modeling. So we're going to start out with different types of models for different analytical types of problems. We want to incorporate purpose statements in our models here. And I want to throw a shout out to Karen Lopez for actually providing a lot of the guidance for this in here. But motivation statements, purpose statements are very, very critical to use. People like to define things, and that's nice, but if you tell them why, it's even more useful. The use of the modeling itself is much more important than the selection of the specific modeling method. I had a colleague earlier this week where he was complaining about the textbooks, wanting to talk about the difference between Peter Chen's modeling versus the crow's feet modeling versus the object notations. It's okay. Just pick one and get over the fact. There's no point in arguing about the specifics on this. We do such a bad job in college and university, it doesn't matter, and you can learn this stuff very, very easily. The models adopt to change very, very quickly. They have to be seen as living documents. So anytime you're looking at a model, you're looking at a snapshot of how things were. The models, of course, must be searchable, because if we can't get a hold of them, it doesn't do us any good at all to have them created. Finally, utility, of course, is paramount, so doing things like adding color and drawing objects and clip art and things does not hurt the utility of your model at all. Now, most people, when they see a house like this, they go, wow, that has a very poor foundation. I don't like the way that looks. It doesn't look like it's good. The question is, what does the customer actually need? And if all the customer needs is to add a satellite dish to the roof of that house, this house is perfectly suited for that particular purpose. However, I hope that you agree you would not put any more money into this house because of the cracked foundation. This will eventually become a pile of brick and rock and broken glass and wood and all sorts of other things in there. But again, think of management's perspective on this. They simply think what they're getting is a house, and that's all they think about from that perspective. So if we're looking at levels of abstraction, the models are downward facing, looking at detail, and architecture is a higher level of abstraction where the concept is really much more around integration. In the past, architecture has attempted to get a perfect understanding, but I've already said to you the models are living models, so it really represents a snapshot. It is not timely to try and get the whole model. In fact, the entire field of enterprise architecture modeling really has been pretty much given up, because if you take the 3 years it takes you to make a model, you then have a really good model of the way the organization used to look 3 years ago. It's just not a feasible approach. Instead, what we need to do is find specific architectural components that need to be re-engineered. We'll govern that process by a framework which gives us more immediate utility in the entire process. So if I was to show, again, management something like this, yes, it's an accurate, perfect, correct diagram, but nobody's going to spend the time to look at it. So we looked at this diagram as well. Again, this is back to our web people. Okay, web folks really get that the information architecture of a website is how you connect people to the content that they're looking for. You'll see diagrams like this all over various web pieces, showing how, in this case, you could go very deep in the blue section that's there, or very broad in the green section that's under there. Again, web developers understand information architecture. What you're seeing here is that we take data structures and we organize the details into larger components. We then take those larger components and organize them into models, and the models are then organized into an architecture. The actual details of this are that attributes are organized into entities. This is the most granular level. Entities and objects are organized into models, and models are organized into architectures. Now, we can produce examples of attributes. Again, my age would be an attribute on my party model, if that was the way we were going to choose to represent this. So I'm 59 at this point in time, and that would be something we could verify. The entities then can be organized into models. My age may be plugged into something like the Alcoholic Beverage Commission here in the state of Virginia, where I'm at today, and they would look and say, yeah, you're old enough to buy alcohol, and you know, that's okay. We don't have very good models of architecture, though, because the architectural models are so complex. It just takes a lot for us to figure them all the way out. So attributes most granular, architectures at the most abstract. Let's take a look a little further at how data must be architected in order to deliver specific value. First of all, those of you that are not familiar with the number 42, number 42 is the meaning of life, the universe, and everything, according to the Hitchhiker's Guide to the Galaxy, one of my favorite books and a very popular book that we've used a lot in this industry to talk about specific things. So 42 is a fact, and we pair it with a meaning. I'll give you a fact. 42 is my age 17 years ago. Do you care? No, not really, but nevertheless, I've made data by saying the fact that I was 42 17 years ago. You can now figure I'm pretty much okay to buy adult beverages. We now need to move to an information layer, though, and that information layer is when we combine the request for information. Probably nobody's going to ask what my age was 17 years ago. On the other hand, they may ask if I'm old enough to buy alcohol. So that would be, yes, Peter, it's perfectly suited for buying alcohol at the appropriate times of day, et cetera, et cetera. What really, though, gets to us is that we have to talk about strategic use of the information, and that's when we get up to intelligence. Now, notice here, even in this explanation, I have given you an architecture. I can't do information without doing data, and I can't do intelligent use of information, strategic use of information, without doing both data and information. I can't skip those other pieces. They are necessary but insufficient prerequisites to actually figuring out how to strategically use our data in this particular organization. And that data is part of the data that's organized, part of it isn't so well organized. This definition's been around since 1983, and I'm still surprised that most people don't actually try to utilize it. It's a very, very clear explanation. Think about how data structures, how architectures support organizational strategy. There's two answers for it. First one is achieving efficiency and effectiveness goals. Now, that's important. If I have a restaurant and my restaurant has a different dish for every item on the menu, must be a nice restaurant, right? And I drop on my way to a customer a peach cobbler dessert, I have to go back into the back and find the next peach cobbler dish. But if my goal of that restaurant is speed, I may serve all of the dishes on the same plate, and when I drop one, I just need to get the next one off the stack. That's part of the efficiency. The other part of it is we provide the organization dexterity. So somebody may say to the organization, the restaurant I'm giving you this example here, you know, I'd like to serve strawberry, so I want a strawberry dish. Well, I'm sorry, we don't have a strawberry dish, therefore you can't put strawberries on the menu. What a terrible answer to a customer. Whereas if I have the ability to be more dexterous about my process, I will now be able to start serving those those strawberries in the restaurant much, much faster than having to actually create the dish. Again, the data structures are going to be critical to this. And of course, we've already seen the data structures comprise the architecture. Here are just some other questions that can be answered by architecture. How and why do the data components interact? Where do they go? When are they needed? Again, I won't read these for you, but you'll see that there are lots and lots of different uses that we can make of a data architecture all the way around. Now, one of my favorite diagrams is this one that we created well over 20 years ago to explain this to some executives. There is an organizational need of one form or another, and that organizational need for information becomes instantiated and integrated into a data or information architecture. That information architecture specifically authorizes and articulates some form of data information system requirements. The problem is most people think you're done when you do that once. As we all know, if we get older, you never get it right the first time. So you need a feedback loop in there so that you can say, hey, did we get it right, and can we continue to utilize that in the process? Then they say, now can we stop? And my answer is no. The only time you can stop is when your organizational needs become fixed and permanent and will never change from this day forth. I don't know about most of you guys. I haven't worked for very many organizations that actually have that much solidity about their purpose. So very important in order to do that. Let's talk about how you now use these to leverage things. And leveraging is an engineering process. You'll notice in my lever example that I have up here, there are two specific technologies. There is a fulcrum and a lever. You could move the large thing on the left with a lever without the fulcrum, but it would be harder. If you instead try to reduce the amount of effort that it's going to take, you apply the correct technologies. And that gives us then a process component. We need some people to do pulling on the lever, and by pulling on the lever, I can then move or leverage the data. Now, I've got one other note on that piece as well, which is rot. All right. So organizations need to better manage their sole, non-depletable, non-degrading, durable, strategic asset data within the organization and, of course, across our organizational partners. And the leverage comes from the implementation of a coordinated technology, process, and human, or people, process, and technology approach to this. The rot part is that 80% of the data in your organization is redundant, obsolete, or trivial. So really what we want to do with that is get rid of it, move it out, find out where it is, and then eliminate it. The bigger the organization, the greater the leverage potential exists. And treating the data more asset-like simultaneously helps us to lower IT costs and increases knowledge worker productivity, both of which most organizations are pretty interested in doing. Now, this next chart here is a little bit complex, but what I'm talking about here is the problem space that we're facing. We all know what as is and to be. To be is what we'd like to have, as is what we actually have. Remember back when we started this, we said all organizations have information architecture. The question is, do they understand what they have? There are three flavors of architectural drawings that we pull together in order to do this. Conceptual, highest level; logical, a little bit more detailed around certain things where we start to get at specific structural pieces; and then of course the physical implementation that we need to have here. Most people think this describes our world pretty well, but you'll notice I have one other dimension on it here too, which is that all of your models are unvalidated until they are actually validated. Validation of models is an absolutely crucial step in doing any sort of information architecture work, because sometimes the metadata lies. I'm sure some of you have some examples of that we can talk about, but it is very, very critical to take this. Now, everything we do in information architecture is in some space here. So I may start out with a physical as-is model and say I have some new requirements that I need to put in place, and those new requirements will then be moving us into our to-be space, our desired space that we'd like to have. In most cases, we can map every transformation into this framework, and we're trying in general to move from conceptual to physical and from unvalidated to validated spaces. There's probably some good PhD work in here that somebody needs to do at some point. I'm too old to do it, but I'm sure some of our grad students will be able to come up with more mathematical representations on this, which would be helpful at some point, because we're faced with a world today where we talk about IT or application-centric development. It is easy to see how this came about. In support of strategy, organizations implement IT projects, right? I need to do something, and therefore I need some IT in order to solve it. Well, unfortunately, this is wrong, but let's go ahead and follow what happens here, because when I do that, I then discover that data becomes the tail wagging the dog on this. So if I say SAP is something that I need to have, and SAP is perfectly fine software, very, very well engineered, but the discussion becomes all about SAP and how does SAP use data as opposed to how the organization uses data. The answer, of course, is it needs to be a combination of both, because as long as we're doing IT and then data, this ensures that the data will be formed to the applications and not around the organization-wide information requirements. That our process architecture is narrowly formed around the applications, resulting in very, very small amounts of data that are being reused across organizations, hence the amount of rot that we have that I talked about on a previous slide. So the transformation is, let's talk instead about data-centric development. Unfortunately, we haven't written the textbooks on this, so consequently they're not being taught in college and university, but let's just see what would happen if we did it this way. If I start out with an organizational strategy and I drop down to data and information, and then, and only then, authorize IT projects, just as I showed you a few minutes ago in the Defense Department when we put that data model architecture component that I showed you before about persons, employees, and jobs, that allowed us to select the software, because if the software didn't match that strategy, then the software was going to require more work in order to actually make it useful. The advantages, of course, to this approach are that the data information assets are developed from an organization-wide perspective, that the systems support the specific data needs and complement the existing organizational flows, and we can finally start to maximize our data reuse on this. Now, these architecture pieces are important. It's very difficult to have architecture without engineering as well, so architecture is used to build and create systems that are too complex to be treated by engineering analysis alone, meaning they're just really big projects. The architects require technical details as the exception, and the engineers develop the technical designs, then employing craftsmen to deliver the various components, like a building component manufacturer, et cetera, around this. I love showing this particular slide to audiences. There's a couple of attributes that are really interesting to it. First of all, it's taller than I am. It has a clutch. It was built in 1942, and it's still in regular use today. Now, you may look at this and say it's a mixer, but why would a mixer need a clutch? And the answer is, in 1942, the United States of America was losing World War II quite badly. And so we sent 4,000 soldiers onto the USS Midway and had the ship go out in the Pacific with all these brave soldiers on it, war fighters that were on it, and they needed something every morning. Breakfast, lunch and dinner, of course. Food, in other words, very basic of Maslow's hierarchy there. This food needed to be a reliable piece, so they made sure that this mixer was able to be used under all kinds of conditions. And in fact, even though it's 80 years old at this point, it still works. If you're joining us in San Diego, let's see, 2 months out, right, Shannon? 2 months out, we're going to be in San Diego. You will actually have a chance to go on the Midway. It's one of the wonderful attractions of the city of San Diego, and they have a terrific tour that they take through it. Now, I popped this little KitchenAid up. Some of you may have a KitchenAid at home. KitchenAid is a fine piece of equipment, but if you're going to try to make pancakes for 4,000 soldiers, I don't think the red one's going to work as well as the blue one is going to work. Engineering also leads us to the world of standards, and standards are incredibly important, even in some things like concrete blocks, right? There are various levels of standards, and we understand these standards, and we can make use of them in a variety of different ways. Well, same thing here. We're going to be talking about architectural work products. All I'm saying is don't eat the whole elephant, just eat the ear or the hoof or the tail or whatever it is that you need to eat in order to do this. So I've got a couple of examples here. We can talk about drawing lines around different components of the system. If we were working in a PeopleSoft environment, we could talk about specific modules that would be important there. Here's an example of a hierarchical system decomposition. It's just showing that system X has 3 processes, and process 1 is more complicated than process 2 and process 3. Or, by the way, it might also tell us that only process 1 has been documented and process 2 and 3 are not well documented, but at least we can name them. So again, what is your metadata actually saying to you? Here's a 3-level decomposition from one of the payroll systems I was talking about a little while ago. Again, the idea here is when we're looking at these systems, find some subset of those systems that you can change without having to worry about missing out on some of the bigger pieces. Here's another example. This is a relatively complex piece from a healthcare system, CHCS from the Military Health Service. I was out in St. Louis a couple weeks ago and actually had some of the documentation with me, and I was able to present the DoD CIO with some of the original documentation that, by the way, is still pertinent and relevant to it. The initial architecture is still the same architecture that we had on that system. That's been well over 30 years since we've looked at that. Let me give you one more set of models that comprise an architecture. This is the state of Virginia. It's our Department of Social Services. So our strategic level data model, our information architecture for it, was viewable from a couple of different perspectives: taxpayers, clients, governance, program delivery, and vendor perspectives. So if I put the first one up at the taxpayer view, you can see there were 4 entities that were specifically pertaining to how taxpayers interacted with the social service programs. If I switch now to the client view, you'll notice that the payments stayed the same, but now we've brought in client benefit, local welfare agencies within that particular piece. Let's move a little bit further. Here's the governance view. This governance view tells us that it's more complicated. Gee, government, I'm surprised it's more complicated, right? So we have a lot of other components that we bring into here. Here is another one for the program delivery perspective. The local welfare agencies hire service delivery partners to deliver specific social service programs to specific subsets of clients. And of course, the vendor perspective is concerned with delivery as well as payments in order to do this. And when we put all of those pieces together, we have a very articulate description of the information architecture required to provide social service programs to people in the Commonwealth of Virginia. Let's go into a specific case study now. The background of this one was a non-government organization, an NGO, somebody that's not in the private sector but in the public sector in order to do this. This is a nonprofit. The industry that it was in was trying to address priority health concerns in different countries. So they may be looking at things like HIV and AIDS or malaria, et cetera, within there. They wanted to provide leadership training in particular so that they could help the organizations better address some of the endemic problems that they had. And they had a health information management system. Most folks do, right? So the function was to look at project management and design specific solutions that were needed by specific health challenges in the organizations. And it operates around 30 different countries around the globe. The problem was that the data needed to make those key business decisions was not accessible across the enterprise. We ended up with timeliness issues, accuracy issues, and of course, isolation issues. The isolation issues were that the data existed, but somebody didn't know where it was or how to go get it. When we look at the root cause, there was no enterprise understanding of the data assets in there, so we pulled together for them a conceptual data model, and now this NGO has a enterprise-wide taxonomy. It didn't at the time, but now it has a existing system and data architecture, which it supports the vision. The original one was not aligned with the business model, and the organization was, as most organizations are, kind of prey to shiny object syndromes. Just buy this piece of software and it'll work. Again, that's just generally not the right approach to it. So the solution, of course, was to make the data architecture articulate, to put in place a specific business glossary and a conceptual enterprise data model that was now able to be used. So what you're seeing here is a high-level description of how that worked out. Again, the 10,000-foot view representing the processes, the procedures that make up the various architectural components. They looked at a specific federated data architecture because that was the one that best supported the organization, mainly because of the way their partnershiping was structured on this. Has a set of entities, in this case projects, that have a level of autonomy to support the goal, while the unifying entity, the shared services that were coming in from the corporate, provided the framework on how to manage and use the culture. So here's a start of the enterprise taxonomy. I won't show you the whole thing here, but you can see very, very clearly this became the vocabulary that this organization needed to implement in order to come up with meaningful business decisions, and most importantly, so that their conversations that they had with each other were able to be articulate, were able to be understood. There's many organizations that we've worked with, we call it a controlled vocabulary. Again, some people get into fancier things like taxonomies and ontologies, all of which are good. I wouldn't try to explain those to the business folks, but if you talk about a controlled vocabulary, it's very useful because they understand the purpose of this. So here's a piece of their overall data model. Again, what you're looking at is the linkages across the functions. So you're seeing the basic chunks. There's financial management in the pink on the right, talent management in the lower left-hand corner, project management, which was a bigger piece, the green that's there, and of course business development in the sense that how can we help support the mission there. So this shows the linkages across the functions, how the data actually flowed through the enterprise. When a data change was made, what was the impact? We were able to figure that out. It defines a common vocabulary, I already mentioned that, and aligning the data in support of the organizational strategy. So this is not their data architecture, although it's certainly a component of it, but you can now start to see hopefully the utility of this in here. Now they have better ability to support the organizational strategy. They were able to come up with some specific reduction in IT costs. They were able to reuse their data asset knowledge. They were able to provide reporting in a more timely and efficient fashion. Defining the common vocabulary, again, resized and moved, they were able to understand what all of these things meant, getting to a common understanding between business and the IT in order to do this. As far as reducing costs, it was amazing. Again, guiding IT on software implementation, when we said these are the needs of it, we found out very clearly that some software that was proposed for the organization didn't work, and other software that was proposed for it did work very, very well. So again, it mitigates the occurrence of poor software practices, because usually you only discover that the software doesn't work after you install it and get it to run, and that's really the last place you want to discover it. It, of course, also reduces the cost of implementations, which means we could do a better job maintaining and managing the data landscape. The IT architecture allows the organization to maintain these critical pieces, and again reduces the cost of trying to manage and maintain everything out there. Back to our rot concept, as in if it's rot, we don't want to do it. It just gets in the way. Now remember, 80% minimum, and the only argument I ever get with people is it's not 80%, it's 90%. So in our category of reusing things, there was knowledge of how the organization's data could be leveraged, and increasing the organizational learning. We had some very big training developments that were coming out as well. Allows IT to focus on the critical assets as opposed to all of the assets in there, and allows us to implement reuse in a much more meaningful fashion. And again, when we understood how IT was going to upgrade various components of the system, we knew what the impact on data flows was in advance. Finally, one last category, accurate and time reporting. There we go. Sorry, I hit the wrong button there. So faster time to reduce time to building reports. There was now a single source of truth, much less massaging or munging of data, and we were able to measure specifically the amount of decreased errors that were in this, and improving the productivity of knowledge workers as well. So let's take a couple of takeaways here in the last 5 minutes. If you're having trouble justifying this to somebody in your organization, you might want to ask them a couple of questions. Would you build a house without an architectural sketch? That architecture is the sketch of the house to be built in the project. If we don't have a sketch of the house, we certainly don't have a really good idea of the value that we're going to get from it. Would you like to have an estimate of how much the new house was going to cost? Your model gives you a very good idea of how demanding the implementation work is going to be. If I said I want my house made out of chocolate frosting, well, yes, I'm sure somebody would build it for me. It wouldn't be very intelligent, but it would certainly be very expensive. If you hired a set of contractors from all over the world to build your house, would you like them to have a common language? The model provides that common language. The information architecture is the thing that provides that common vocabulary so that contractors from different places around the world who speak different languages, as well as the business and IT, can all get on the same page, literally. Would you like to verify the proposals before the construction starts? The models can be reviewed before thousands of hours of implementation work are ready to be implemented. If it was a really good house, would you like to build the same thing over in another place? With those plans you can, but without the plans, somebody's got to eyeball it and get it. That's not happy. Finally, would you drill into the wall of your house without a map of the plumbing and electrical lines? Drills and plumbing and electricity tend not to interact well, which means that we can now make life easier when we're supporting and maintaining the project. Two more slides on this. First of all, what is an information architecture? It's a structure of data-based, not database, data-based information assets supporting the implementation of organizational strategy. Most organizations have data assets that are not supportive strategies, i.e., their information architectures are not helpful. So the real question is, how can organizations more effectively use their information architectures to support strategic implementation? What do we mean by the use of an information architecture? It's the application of data assets towards strategic objectives. It's assessed by the maturity of the practices. I've mentioned that 1 to 5 scale before. It results in increased capabilities, dexterity, and self-awareness of the organization, and it's accomplished through use of data-centric development practices, such as we've talked about here today. How does the organization then achieve better use of its information architecture? And the answer is continuous redevelopment. The starting point isn't the beginning. This is one of the worst things, and you guys know I'm a college and university professor. Why are we teaching kids how to build new systems? It doesn't make any sense. They're not useful to you, they're not understanding how this works, and they never get to do it in the real world. Information architecture components must be re-engineered. There is a technical definition of re-engineering, which means first understanding the existing strengths and weaknesses, capabilities and limitations of our existing system, and then using that information to inform the development of the next one, the next approach. And you do this using an iterative, incremental approach, focusing on one component at a time and applying a formal transformation method that I certainly won't bore you with here. Last slide. Data strategy and data governance in context here. When we look at the information architecture of an organization, what we're looking at is what the data assets do to support the strategy, and the governance piece is how well is that strategy working under the context of the organizational strategy. So this is information architecture at its best, which means that the focus of data governance has to be on improving aspects of the organizational data architecture. That then becomes a necessary but insufficient prerequisite for successful IT project delivery, which means organizational operations are impacted that way. We also, of course, want to have good feedback loops in there in order to take a look at it, in order to take a look at the whole entire process. So I've spent an hour here, a little bit less, talking about how information architecture is a crucial piece. But the only place you're going to get it is to come to these Dataversity webinars, because we don't teach this well in college and university. In fact, I've had several good friends of mine who've helped out where we found out that the instructors were actually teaching students how to do it wrong. That's how little well-known this field is. And it's just a shame, because we know we could help the world in some very significant and fundamental ways in order to do this. So at that point, we get to stop, and we'll welcome Pavel back to the line here. Just want to give a quick plug for the upcoming Enterprise Data World in San Diego. We're going to be there with a lot of other people. Hopefully Pavel will be there as well. And the March webinar is coming up, the importance of MDM. In April will be data modeling fundamentals. But right now, it's time to turn it back over to Shannon for our Q&A section. Shannon.
Thank you so much for another great presentation. I love it. And so, just a reminder to answer the most popular asked question. We'll send out a follow-up email by end of day Thursday with links to the slides from both Pavel and Peter, as well as a recording of this presentation and anything else requested throughout the webinar. If you've got questions for either speaker today, feel free to submit them in the Q&A section. And diving right in, so what is the difference between data and information architecture in a simple term?
That's a great question. Pavel, I'll let you jump in on that after I finish, but I get to go first on this one. I don't like to distinguish between the two. I know that sounds kind of crazy, but I find it is more difficult to try and distinguish the two than it is to try and look at them as a holistic piece. So let me get back to my diagram here. There we go. If you're looking at a diagram that looks something like this, and you may or may not agree with this particular diagram, which was developed by Dan Appleton in the late 80s, but that data is at a lower level of abstraction than information, and that information is transformed from data into information by virtue of the fact of linking it to a request, and that once we understand contextually how that information is used, then we're getting to value in that. I have seen organizations try to maintain data and information separately. The problem with that is that one person's data can become another person's information. So again, if I give the number 42 out, that's a perfectly good piece of data. If I connect that with the fact that I was 42 17 years ago, oh my gosh, do I sound really old. That is still data, but it can also be information if somebody's trying to figure out how to do it. So yes, you could be a purist about this process and try to manage separately data and information, but you will end up costing your organization a lot of unnecessary time and effort. It is much, much more effective to manage your data and information as an integrated whole instead of trying to manage them separately. So the data architecture would be the data piece of it, and the information architecture would be the information piece of it, but there would be no hard lines between them. And because there aren't hard lines between these pieces, it means you're going to get the subjective definitions. Just not helpful. I hope that was a helpful description of that. I like that description. I've been very, very comfortable with it. Let me just pause and see if Pavel wants to jump in and disagree with me, which you're perfectly entitled to, sir.
Now, I don't want to disagree. The only thing I would add, by the way, I do agree totally. And what we see is people sometimes get focused so much on the data side. They start like hoarding data and they are drawn to ideas like data lakes and building things where they can just get data in, but they don't think about why they're doing it and what information they are actually seeking. So it always needs to go hand in hand. Otherwise, we're like building something, but it has no purpose, and the purpose is information.
Excellently stated, absolutely. And remember, I made a statement in there as well. Rather than giving people definitions about your data or information assets, give them purpose statements. Because as Pavel said, if you don't have the purpose, then why are you expending organizational resources in support of that? Super. Great question. Thanks for starting us off with a good one.
Yeah, there's a lot of great questions coming in here. So a hypothetical, I love this hypothetical question. So if you were coming in as the chief data architect into an organization, what would you do in your first 100 days on the job with the goal of getting a data strategy underway leading to a data architecture?
Well, that's sort of a question for a different webinar, but let's go ahead and dive in anyway. 100 days is a very short amount of time to get things up and running, and it does depend on where the organization is on its own journey. But that said, what we're looking at here, and I'm going to switch to another slide, the very last slide that I showed on this, which is the relationship between data strategy, data governance, architecture, et cetera here. The key is we are here to support the organizational strategy. Okay, that is our purpose. That's what we're employed to do, whether we're in a nonprofit context or whatever we're doing. It is for a purpose to support the organizational strategy. That strategy has to be supported by the various assets of the organization. There are some physical assets, all right? There are some human capital assets. You may have some intellectual property that you're putting in place to do all of these things. The data strategy has to be the piece that says, how are we going to take the data that we have and better support the organizational strategy given that set of constructs? If we're not using data to support strategy, we're missing out on a huge opportunity for organizations. And you'll see this happen, and we call it monetizing data. I even have a book out there on monetizing data, on how to do this. Most people think that you just take the data, and if you have the data, as Pavel said, and put it in a big lake, it'll become useful sooner or later. And the answer is maybe it will. But if you keep those purpose statements flowing and say that the purpose of a data architecture and information architecture is to help the organization better meet the strategic objectives of the organization from the data perspective and from integration perspectives, then you will be much better able to articulate that. So within 100 days, I would definitely be, doing a lot of education, making sure everybody understood, doing a lot of listening to find out what are the organizational needs, where are things complained about, where are we not meeting our performance objectives, et cetera, in there. And within that 100 days, I would definitely want to have a plan for the next 100 days of how we're going to start showing improvements all the way around. By the way, Pavel, if you want to jump in before me on these, feel free. We just love to make the free-flowing discussion here. So anything on this one?
I couldn't find the window.
There you go.
No, I think you covered it. Yeah, I finally covered it. No, I'm good on this one.
Super. Next one, Shannon.
This next question is along the same lines, really. How do you define data architecture framework for an existing organization? Just where do you start? Where do you start investigating? You talked about, doing a lot of investigation of where that you're not efficient, et cetera. So where do you start?
Pavel, do you want to take that one first, and then I'll come on?
Yeah, I'll give a non-data architect answer. I would start somewhere where you can see the end of the first journey and sort of see something that brings value in a short to mid-term. Try not to encapsulate everything in a one giant perfect data architecture from the get-go. We've had clients who started small, started in a department, started with a few people, and they saw a great deal of value in building something more and expanding. You can always expand if you do it right. So that would be my take on that.
Again, 100% agreement with you. I remember when I was spending time with Nokia about 20 years ago, and one of their architects, Teemu Matamakia, loved to say this over and over again: think globally, but act locally. And from architecture perspective, I think that's what Pavel was just describing. You could say, I need to have this screen that I've put up in front of you. Remember, this is the State Department of Social Work for the Commonwealth of Virginia's high-level enterprise architecture. And it's nice, but if you wanted to start with that, it would be very difficult to show value. So as Pavel said, find something, we'll call it low-hanging fruit, or quick wins, or something that can be done, so that if I do something around process 3, on this diagram here, that may be a very confined piece. But if you are a good architect, you'll be able to see that the larger picture also will have to be done eventually. So you might do process 3, but you might understand that the entirety of process 1 and 2 also need to be part of that solution. And as a good architect, and with the right tool set, of course, you can implement quickly some things that show very definite value. But if you say, wait, give me 5 years, and I've actually worked with groups that said, I have 5 years. The only problem with 5 years is that most CIOs last between 2 and 4 years. So consequently, your cover ends up being a problem as well. Pick something small, show that you are achieving some value results on it, and Pavel had a slide on that in his deck earlier there, that will allow people to see that what you're doing. Now, there's another piece to it as well. Remember, nobody in IT has been given any education typically on data architecture out of college and universities. So what they pick up is what they've picked up on the job. Some organizations have very well-developed practices, some of them less so. It's important that you also socialize your message, that you have an active communication campaign, just as if you're implementing data governance or any of the other things here, to tell people why you're doing this and what you hope to achieve. Again, under-promise and over-deliver doesn't hurt as well. It's a great question, super motivational.
You know, and while we're waiting for additional questions to come in here, I'll give everybody a couple seconds if there's additional questions. We've talked about the value of data in the past, in previous webinars and such, and you have a book on that as well. As you talk about, that's such an important piece to get executives involved. Anyway, just to even start in this process, I mean, beyond even just how do you start data architecture, how do you get support from the C-suite to buy into it?
And that's a great question, because it is very difficult to convince the C-suite that this is something worth investing in, because after all, they are in existence, they're paying your salary, there's clearly a purpose for which you've been hired in order to do this. But what you need to do is say to them, look, you have people that manage your HR function. And I actually did this one for Walmart. It was kind of a good example for them. Walmart has 1 million+ employees throughout the world. And they have tens of thousands of HR managers that take care of this asset for Walmart. It's a very, very useful component, and Walmart would no sooner part with their HR practices than they would part with their advertising practices. It's a key portion of their business. And then I said, yeah, you've got 3 guys over here named Dave and Fred and George who are taking care of your data. And you have more data than the federal government does. And they kind of went, okay, I think you made your point. We've got 20,000 people that help out with our 1 million employees, and we've got more data than anybody else in the world, and we've got only 3 people that are taking care of it. But this was years ago, so obviously they've gone a long way since then in order to do this. And it was really more about formalizing the practices than specifically we had 3 people formally doing it, but a lot of people were doing it off the side of their desks. And when we added up how much time and effort they were spending, it was still a very efficient effort for them to take a look at on that. Pablo, anything to add on to that? How do you sell this stuff?
Again, trying to. I don't know what else to add. Like, you're so eloquent, it's difficult to add.
Oh, come on. I've been doing this for a while. That's what it is.
Oh, were you?
All right, nothing to add on that one. Shannon, any more questions, or do we hit them all? Sometimes we do.
We've got another question here. So any key difference between traditional versus cloud data lake on big data data architectures?
Fantastic question. So we're seeing lots and lots of people that are pushing cloud, and cloud has some very good capabilities to it. On the other hand, cloud really is just another computer somewhere else. And so I particularly have 3 rules that I like to help my organizations with when they're doing cloud. The first rule is the data in the cloud, and by the way, I'm going to say the same thing for lake because many of the lakes are in the cloud. So, you know, we'll dive into that a little bit more maybe if we need to. But data that's in the cloud or the lake should be of measurably higher quality than data that is not in the cloud or in the lake. That runs very contrary to what most people do. But the question is, if data is on your computer, who's using it? Who's impacted by it? And the answer is you. And if you hand that spreadsheet or whatever it is that you're doing to somebody else, then there's a limited set of things. But once you put it in a cloud or a lake, it's accessible to the entire organization. So I've never found anybody that disagrees with my statement that data in the cloud or in the lake should be of measurably higher quality than data that is not in the cloud. Second rule is that data that is in the cloud should be of more shareable. Now, that is a quality that we can recognize and measure. Shareable data is data that is acceptable to multiple uses. And we can measure how data is used by those data flow diagrams we were talking about a little bit before. If we have data that is less shareable in the cloud than it's not, why are we putting it in the cloud? So data should be of higher quality, it should be more shareable, and that means you have to re-architect it typically. And finally, data that's in the cloud or the lake should be of less volume than data that's not in the cloud or in the lake. Again, completely counterintuitive to most people, but remember, 80% of your data is rot, and I contend it's not 80, it's probably 90% of your data that is redundant, obsolete, or trivial. So unless you just like unless you like paying cloud vendors lots of money to store the same piece of data in multiple places that you don't know about, it's kind of a waste of time to do that. So the cloud makes a perfect spot to transform your data into something that is higher quality, of lower value, but greater ability to share across the organization in there. Pavel, I'm sorry, that's an old saw that I hit, so I went into automatic mode on that. But again, please feel free to jump in and ask any questions.
Well, I would add one interesting thing from the technical side. Cloud is not magic, and what people don't realize is, as you said, it's a computer somewhere else. So when you look up to the sky, you don't see like one giant homogeneous cloud. It actually are like different clouds. So even in a cloud, if you're working with large volumes of data in a cloud, you realize you have to do certain things to make that data local, and you have to be aware of the architecture of that particular cloud, which people don't see, and cloud providers actually don't want you to see in their marketing. So you might end up, like the typical case is for Amazon, you have all those different data centers. And not only regionally, but you have different generations of data centers, which they sort of hide in those different kinds of instances. And that can pose different sort of problems than on-premise data storage, but still, it's something that needs to be managed. Otherwise, you end up with something which might be very inefficient.
And again, the people who benefit from this are the cloud vendors. So I've worked with a health system recently that was a fascinating case study on exactly what you were describing, Pavel. They, the way their terms of contract were, if you wanted to get data out of this healthcare system, what you did is essentially they unloaded the entire set of data that they had in their hosted cloud environment, moved it across to you, paying by the bit as you were moving all that data over to you, and then you would cut it down like an ice sculpture, right? So get rid of all the pieces that we don't need, and what's left over must be the answer that I was looking for. Of course, if you made a mistake in that and cut away too much of it at once, you probably weren't practicing data management very well, and you threw away something that you couldn't just undo. And so then you had to go back and ask them to download it again. And this health system had actually gotten to a corporate culture where they were saying, no, don't ask too many questions. Now, I don't know about you guys, I'd rather have healthcare researchers asking questions so that we can all get healthier faster, but sometimes it doesn't work that way, and so we end up with the cloud vendors getting richer perhaps than they ought to be. Yeah, it sounds like we're picking on them. It's not picking, it's just that people don't really understand the newness of the technology, and that's, I think, what Pavel and I are trying to get across to everybody.
Yeah, there's so many of these questions, too, we could spend a whole webinar or a whole day on, actually, including a couple of these that are coming up. Today, organizations have complex application landscapes. The strategy in business and IT revolve around capabilities and IT applications and tools. So how can you keep showing the need and importance of data quality and data strategy?
The complexity of today's business is really your primary driver for the need for information architecture. The more complex your business is, the less likely it is that one person will be able to understand the entirety of it. So when you're looking at a diagram, and again, I'll just give this one here, which was our NGO that we talked about. This is not an enormously large information architecture, but you can see here, there were at least 4 different subject matter experts that were involved in putting this together, from the business development, project management, talent management, and finance management aspects of it in here. Mostly these folks understood their domain and how their domain interacted with the one that it interacted with. But if you had 2 that were not closely connected, again, talent management and financial management, for example, this became the only source of truth for them to go back and figure out how these things related to each other and what effect was happening in one part of their business when things changed.
Pavel, you want to add anything?
I'm good. Thank you.
Okay. So the next question coming in, so how do you architect data for AI implementation?
Ooh, that's a fun one. In the old days, we used to do Prolog and Lisp, and now we have some more really interesting categories here. What you're talking about from an AI perspective is looking at trying to match what the outcome is with some desired set of constructs. So if I have an artificial intelligence that's going to be a customer service rep, and I'd like to have, for example, robots answering customer service questions, which is a perfectly reasonable thing to do. When you're architecting what that robot needs to, quote, understand in order to respond to these things, those data structures are crucial, because one of the things that happens in AI is that people are reacting in real time. Again, if you call Alexa or Siri and say, hey, right, you want them to have some good response. So you first of all start out with the process of just making sure that you can get the correct answer. But then you need to add on to it the purpose statement that we talked about earlier. Nobody wants to go, hey Siri, and then it come back and go, oh, did you call me, right? We say, hey Siri. If Siri's not right there, we say the system's terrible, the phone doesn't work, something's wrong. Same thing with Alexa. You can imagine Jeff Bezos would not be very happy if Alexa was less responsive than it actually is. So there's a second layer of architecting that occurs. Once we get the right answer, we then have to get the right answer quickly. And by the way, that's just one small aspect of AI. But again, let's go to the Jeopardy example of Big Blue. Or no, it wasn't Big Blue, was it Watson? Watson was what won the Jeopardy thing. If Watson got the right answer, but it was slower than the other 2 people that hit buzzers, it wouldn't do any good. IBM likes to win contests when they do that, so that's a really interesting concept from them. Anyway, Pavel, anything in AI? Have you played in that area much?
To be honest, not much. We have a couple clients who are preparing data for like machine learning algorithms, and they do some clever bits in that. And what we've learned is it's an interesting space where the data sets look very different from the traditional ones. We've seen clients who had like 17,000 data points or fields in like a single record, which is quite challenging for the technology. And that's sort of new compared to like traditional data implementations, but we don't play much in that space, to be honest.
But you did hit the high point, which is that there is a purpose to it. So in a transactional system where we're dealing with checking accounts or orders or products and things like this, again, traditional if you will, but it's not all that traditional in today's environment, you know, the data needs to be organized in one fashion. Taking that data architecture and then expecting it to work in a real-time situation is completely naive. And so consequently, the need for the ability to come in and architecture data for a specific purpose is something that all organizations have a need for. One of the slides I didn't throw in this deck because I had 96 of them already, so I just want to kill you guys to death with PowerPoint, but there's another one that says that if you're in a software packages environment, most people say, well, it's all based on software. We do not need to have any sort of a data architecture because software is taking care of it for us. The data architecture is the only thing that tells you how your software interacts with the other pieces of software that you're having in your environment. So the more you're reliant on commercial off-the-shelf software, the more reliant you are on your data architecture. And we find a specific correlation there that says that most organizations say, we got software, we don't need to have the data stuff doing it, and it won't work well anyway, and they are the ones that end up being problems. Anyway, great question.
So would you say that moving data to the cloud emphasizes the importance of data architecture?
I would, although I don't see it in practice. Again, Pavel, you're probably closer to that than I am. I tend to come in when it's been moved over and they can't get the results that they want, and I show them that, yeah, the way you put it out there, you could never get the results that you want. See, cloud vendors are incentivized to sell you lots of cloud services. So they have very little incentive to make sure that you're in fact solving the right specific problem. The more you approach it, the more you do, the more money they make while you're figuring out the solution. And that's just not really a good partnership there. So Pavel, I'm sure when you guys do this, you guys actually work with the customer, try to find out what their specific needs are, and then talk how our architecture can be used to solve this in a number of different ways.
Yeah, absolutely. Like we always look for the purpose, and also I saw some in some of the questions that people are asking about which 10% of the data is useful and how to identify that. Well, that's not the right approach. The right approach is what is it you need? Like go asking people what they need and what sort of data architecture and data structures they need to be looking at to get some value from it, and then find out where to find the data for that to get that information, rather than like being overwhelmed of all the data you have and sort of trying to cherry pick which one is important and which one's not. It's the other way around that makes sense, and the same with cloud architectures. Like yes, the cloud vendors will try to get all your data in there in any form. They'll send trucks that you load your data on.
I've seen that, yes.
Yeah. But the purpose and the shareability, as you talked about, is I think the key thing to think about before actually jumping on some cloud architecture.
And that goes back to one of our first questions, which was the data strategy question. So absolutely.
All right, well, I think we have time for one more question here. So, Pavel, I know you're going to have an opinion on this one. So, can you compare different types of integration techniques, ETL, virtualization, messaging, so et cetera? So, when would you use each one?
Fantastic question. Go ahead, Pavel.
It very much depends on finding out what your users need. We're seeing, I'll answer it with some reality. There's a big shift from this traditional like batch processing, get the data done by 6 a.m. every day. We're seeing a shift towards more like fluid data architectures where things interoperate on more like real-time basis. The real-time thing is often quite misunderstood. It's more like near real-time, where if something happens somewhere, then it triggers some process, which is fairly quick, small batch that happens quite quickly, so that within a couple of minutes, let's say, there's the data architecture that gets updated. I think it makes sense to think about what you actually need, because going real-time might be more challenging than doing something simple, and the simple thing might be enough. So I would recommend not to get sort of fooled by all that marketing that surrounds some of the modern approaches, and always think what it brings, what value it brings. And if it doesn't bring a value, then it's probably a wasted investment.
I have nothing to add to that, Pavel, except that you said earlier on, it's really critical to make sure that your architecture is driven by specific needs. And so consequently, the better you understand those needs, and the better you, as working as a vendor with your clients, understand those needs, the more likely you are able to come up with the right solution in there, starting small but thinking large.
Yeah, totally agree.
All right, well, I'm afraid that is all the time we have for today. Peter and Pavel, thank you so much for this great interaction, and thanks to our attendees for being so engaged in everything we do. We just love all the great questions that have come in today. And as Peter is bringing up then, we hope to see everybody in the March webinar, The Importance of MDM, on March 13th. And again, thanks to everybody, and I hope everybody has a great day. Thank you so much. Again, Peter and Pavel, thanks again to Clover ETL for sponsoring today, and we very much appreciate it.
Thank you, Shannon.
Thank you.
Great day.
As well. Yep, and look forward to the next one. Cheers, everybody.
Cheers.